Okay guys, so right now you should have this top chart filled out, practicing the protons, electrons, valence electrons, oxidation number, and type of ion from identifying it on the periodic table. What we're now going to do is draw an ionic bond using a Bohr model for the first two problems on the front page. So the first one we're looking at is potassium. Potassium is a metal in group 1. The atomic number is 19, so it has 19 protons and 19 electrons. For right now, I'm just going to focus on the electrons. So when I have my potassium symbol is K, and I'm going to draw my first orbital. Okay, and I also like to remind you that on your periodic table, yours may have it, there are period numbers off to the side. There are 7 periods on the periodic table. They tell you how many orbitals or circles you need to draw. So potassium is in period 4, so I will have 4 orbitals to begin with. So I've got 1, 2, 3, and 4. Okay. So in the first orbital, it can hold up to 2 electrons, and I've got 19 to place, so I'm going to put my 2 in there. Then I'm going to go to the next one, so we're going to go with 8 in the second orbital. Okay. Then I'm going to go to the third orbital, and that will be 8 again. Okay, so right now I'm at 18. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and here's that 18, and this is 19. Okay, and then these are the electrons. Okay, now I'm going to draw fluorine. Okay, fluorine, get out my periodic table, is a non-metal. It is in period 2, so it'll have 2 orbitals. The atomic number is 9, so it's going to have 9 electrons. So I'm going to go ahead and draw my fluorine. So I'm going to put the little symbol here. And then again, period 2, so 2 orbitals and 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Notice how both atoms are incomplete. You know, the goal is to be stable, to look like a noble gas. So potassium, to look stable, okay, potassium right here, it's going to be easier to lose this electron, to give it away, and kind of go back, sorry, move it over, go back one space to look like argon. Fluorine, it's going to be easier to find fluorine and electrons so it can look like a neon atom. So that's just what happens here. Okay, potassium is going to, oh, that's kind of hard to see. Potassium is going to give its electron to fluorine. Okay, when it gives its electron to fluorine, it now becomes an ion. It loses an electron. It's losing a negative, making it a +1 charge, and that's now formed a cation. Fluorine has now gained an electron. If it's gaining a negative electron, the atom becomes more negative, and it now becomes an anion. Both elements are now stable. Both elements look like a noble gas. Potassium losing an electron, looking now like argon. Fluorine gaining an electron, now looks like a neon atom. So now let's look at the bottom here. Magnesium chloride, or chlorine. Okay, magnesium. All right, magnesium has the atomic number 12, so it's going to have 12 electrons. It's in it's in period 3, so it's going to have 3 orbitals. So I'm going to draw my magnesium with the 3 orbitals. 1, 2, and 3. Okay, and then again 12 electrons. So 1, 2, 2 in the first shell, 8 in the second shell. Okay, that makes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 11 and 12 are in the outer shell. Okay, so it's not stable. It wants to look like a noble gas. So it's going to be easier for magnesium to try to lose the electrons to look like a neon atom. Okay, chlorine, which is our next element. Chlorine is a nonmetal. It is 17 atomic number so that means for 17 protons and 17 electrons. And it's in period 1, 2, and 3. So it'll have 3 orbitals. So I'm going to draw my chlorine here with its 1, 2, and 3 orbitals. Again, I said the atomic number was 17, so it'll have 17 electrons, 2 in the first, 8 in the second orbital, and 7 in the third. Okay, so it'll be easy for chlorine to find an electron right here to look like argon rather than to get rid of all 7. And that's just exactly what happens. Magnesium is going to give its electron to chlorine. Chlorine now has received an electron, and it has become an anion, receiving that negative electron, making it more negative. All right? Now let's look at magnesium. Okay? We're not done with magnesium. Magnesium had 2 valence electrons, and it only could give 1 to chlorine. So magnesium's still not happy. It's still not filled in terms of its outer shell. It has to get rid of this extra electron. So what we're actually going to end up doing is drawing another chlorine atom. Right? And when we draw that second chlorine atom with its 17 electrons, magnesium now has an opportunity to get rid of that extra electron. Right? So when that happens, the chlorine still is a -1. It's still an anion. But let's look at magnesium. Magnesium didn't lose 1 electron. It now lost 2 electrons, which now makes it a +2. When you lose an electron, the atom becomes more positive, and we call that a cation. So sometimes on your homework, you may have to draw more than one type of atom to make your bonding complete, just like we did here. We drew 2 chlorine atoms in order to make the magnesium complete. So be mindful of that when you do your homework. You're now going to do the back side, and good luck, and always check the video again if you need extra help.